The US Navy spent $500 million building a weapon that fires projectiles at Mach 7 without gunpowder. No bullets, no explosions, just electromagnetic force launching metal slugs at hypersonic speeds. In 2021, they canceled it. Better life. Less than 30 shots before replacement. Rate of fire, too slow for combat. Power requirements. Only 3 ships in the entire fleet could even operate it. $500 million. 15 years of development. Completely shelved. But here's what nobody's telling you. That failure wasn't the end of bullet-free weapons. It was just the beginning. Because while the railgun died, 3 other technologies survived, and one of them is already killing bullets faster than any weapon system ever built. By the end of this video, you'll understand why the military desperately wants to eliminate bullets, and why it keeps failing every single time. So will future soldiers still load metal-cased bullets into magazine-fed rifles? The answer will surprise you. Every rifle bullet you've ever seen has 4 parts. The projectile that flies down range, propellant that generates gas pressure, a primer that ignites everything, and a brass case holding it together. That brass case weighs more than the bullet itself. A soldier carrying 200 rounds of 5.56 millimeters. Ammunition holds around 3 pounds of brass that gets ejected and left on the battlefield. Multiply that across an entire infantry battalion and you're talking thousands of pounds of metal that serves no purpose after firing. The U.S. Army's Lightweight Small Arms Technologies Program LSAT proved you could eliminate brass entirely. Caseless ammunition encases gunpowder in solid combustible polymer that burns completely during firing. The weight savings are dramatic. Soldiers can carry 40% more ammunition for the same load. Germany's Heckler & Koch G11 rifle firing, caseless ammunition worked perfectly in trials during the 1990s. The weapon was ready for mass production. Then the Cold War ended. Defense budgets collapsed and the program died. But that's not why caseless ammunition didn't replace bullets. The real problem emerged during sustained fire tests. In conventional ammunition, the brass case absorbs heat and gets ejected, taking thermal energy with it. Caseless systems keep all that heat in the chamber. Fire too fast and catastrophic failures occur. Worse, you risk cook-offs rounds, igniting from residual heat before the trigger is pulled. The U.S. didn't give up. In 2022, the Army adopted the Sigma Spear as its next-generation squad weapon, chambered in a hybrid brass-steel cartridge that's lighter than full brass but prevents the heat problems that killed caseless designs. So bullets survived the first challenge. But engineers weren't done trying to kill them, and that's when they realized the real problem wasn't the bullet, it was heat, which led to something far more dangerous. Railguns use electrical current instead of explosives to launch projectiles. 2 parallel conductive rails carry massive electrical charge around 5 milliamp. When current flows through, it creates a magnetic field that accelerates the projectile down the barrel using the Lorentz force. No gunpowder, no chemical propellant, just electricity and magnetism. The results are staggering. The Navy's prototype railgun fired projectiles at 2,520 meters per second, Mach 7.5, and for comparison, an M16 rifle fires at 930 meters per second. The railgun was more than twice as fast. At those velocities, kinetic energy alone destroys targets. You don't need explosives in the warhead. A 23-pound slug traveling at Mach 7 carries the energy of a school bus moving at 316 miles per hour. It punches through armor, concrete, and fortifications like paper. The range was equally impressive, over 100 nautical miles. That's 10 times farther than conventional naval guns. And because you're not storing explosive ammunition, ships become safer. No magazines full of gunpowder waiting to detonate if hit. For a brief moment, it looked like bullets were finished. If the Navy could fire projectiles electromagnetically at Mach 7 from ships, infantry weapons would eventually follow. Handheld railguns seemed inevitable. Then reality hit. The barrels wore out catastrophically fast. Defense analyst Norman Friedman noted that a normal gun barrel fires about 600 times before refurbishment, while the railgun barrel needed replacement after a dozen or 2 dozen shots. The extreme forces megampere currents combined with hypersonic projectiles melted rails and caused rapid erosion. Each barrel cost hundreds of thousands of dollars and required specialized manufacturing. In sustained combat, you'd burn through barrels faster than factories could produce them. Power was the other killer. A railgun firing 12 rounds per minute requires 30 megawatts of power. That's enough electricity to power a small town. Only the Navy's Zumwalt-class destroyers generate sufficient power. An event then firing the railgun meant diverting energy from other systems. For ground forces, it's completely impractical. An infantry soldier can't carry a portable nuclear reactor. Trump announced in December 2025 that new battleships would be armed with electromagnetic but military analysts remain skeptical. The fundamental problems, barrel life, power requirements, maintenance costs haven't been solved. If the barrel problem had been solved, bullets wouldn't exist anymore. And one country believes it has solved it. But while the railgun struggled, another technology succeeded where electromagnetics failed. And it's already replacing bullets and rolls nobody expected. While railguns failed, directed energy weapons succeeded. And they're not experimental anymore. In 2025, the U.S. Navy deployed the USS Preble with a Helios 60-kilowatt laser system fully integrated into its Aegis combat system. It successfully destroyed an aerial drone during testing. Israel became the first nation to field combat-ready laser air defense when Rafael Advanced Defense Systems delivered Iron Beam to the Israeli Air Force. In October 2024, Iron Beam reportedly intercepted 40 Hezbollah drones during actual combat. The cost per shot, approximately $3. Compare that to missiles costing millions. Senator Angus King noted the economics. Hostile drones cost around $10,000, while an SM-6 interceptor missile costs $4.3 million versus $12 for a directed energy shot. The U.S. Army is deploying 50-kilowatt lasers mounted on Stryker vehicles as part of the Directed Energy Maneuver Short-Range Air Defense Program. These aren't prototypes. They've been tested in operational environments and sent to combat zones. Australia's EOS Apollo system can destroy up to 200 drones on a single battery charge. The UK's Dragonfire laser can hit targets the size of a coin at long ranges for about $13 per shot. China has deployed laser systems on naval vessels. The directed energy arms race is happening now. At this point, it looks like lasers are the answer. Cheap, effective, already deployed bullets should be obsolete. But lasers have a secret weakness that bullets exploit perfectly. Weather degrades performance. Rain, fog, and smoke scatter laser beams significantly. Lasers need to stay locked on targets for several seconds to inflict damage, making them less effective against fast-moving threats. They excel at destroying drones, small boats, and rockets, but struggle against hardened armored vehicles or supersonic aircraft. Range is also limited by atmospheric conditions and power levels. Current 50-kilowatt systems are effective out to a few kilometers. To engage targets at longer ranges requires scaling up to 300-kilowatt or even megawatt-class systems, which creates new engineering challenges. The Pentagon is spending approximately $1 billion annually on directed energy research. Lockheed Martin delivered 300-kilowatt systems to the Army. The Navy is pursuing 400-kilowatt shipboard lasers through the Songbo program. Lasers are winning specific battles, but they're not winning the war against bullets. And that's when engineers discovered something that changes everything. Here's what every alternative technology discovered the hard way. Energy density. A rifle bullet weighs a few grams and carries enough kinetic energy to stop a human threat instantly. It works in any weather, requires no external power source, and penetrates cover. You can carry hundreds of rounds. A laser powerful enough to replicate that lethality would require a backpack-sized battery pack that drains after a few shots. The energy density of gunpowder remains unmatched for portable weapons. For infantry combat close quarters, urban environments, trench warfare bullets still dominate because physics hasn't changed. A soldier can carry 200 rounds of ammunition weighing a few pounds. An equivalent laser weapon would need battery packs weighing tens of pounds and providing far fewer shots. Until battery technology advances dramatically, think compact fusion reactors or revolutionary energy storage bullets stay, but something unexpected is happening. The bullets staying aren't the bullets we started with. The Army's adoption of the 6.8 by 51 mm hybrid cartridge represents a shift toward lighter, more efficient ammunition. Polymer-cased ammunition is gaining traction, reducing weight while maintaining performance. By 2026, manufacturers like Hornet, Federal, True Velocity, and Winchester are pushing polymer ammo from military exclusivity into mainstream availability. Electromagnetic propulsion for handheld use remains 10 to 15 years away from commercial viability. Plasma and directed energy rounds are being tested for law enforcement and special forces but won't be fielded widely for at least a decade. But the biggest change isn't eliminating bullets, it's making them smarter. Adaptive guidance systems are being developed that use fins or electromagnetic control for flight correction, primarily for military applications, but with civilian adoption growing. DARPA's Exacto program already demonstrated self-guiding bullets that adjust trajectory mid-flight to hit moving targets. So, bullets survived every challenge thrown at them. But that doesn't mean the war is over. Because what's coming next makes everything we've discussed look primitive. The next decade will see three parallel developments. First, widespread adoption of hybrid and polymer-cased ammunition across NATO forces. The weight savings allows soldiers to carry more rounds, and the reduced logistical burden makes supplying forward units easier. This is already happening. The M7 rifle fielded to U.S. forces uses SIG's hybrid breast steel cartridge. Second, lasers will become standard defensive systems on ships, vehicles, and forward operating bases. The Army is working on 20 to 30 kilowatt systems for joint light tactical vehicles, 50 kilowatt systems for Strykers, and 300 kilowatt platforms for larger vehicles. These will intercept drones, rockets, and missiles, filling gaps in layered defense that conventional weapons can't address cost effectively. Israel's Iron Beam integration with Iron Dome, David's Sling, and Arrow creates comprehensive protection where laser systems handle short-range threats while missiles engage longer-range targets. That model will spread to US and NATO forces. Third, railgun technology won't disappear entirely. It's just not ready. The fundamental physics work, the engineering challenges are solvable with better materials, science, compact power systems, and improved thermal management. China continues pushing railgun development. If they achieve breakthroughs in barrel life or power generation, the US will restart programs immediately. But for now, the Pentagon is betting on hypersonic missiles and lasers instead. Infantry weapons will remain kinetic for the foreseeable future because the energy density of chemical propellants can't be matched by portable power sources. A soldier can carry 200 rounds of ammunition weighing a few pounds. An equivalent laser weapon would need battery packs weighing tens of pounds and providing far fewer shots until battery technology advances dramatically. Think compact fusion reactors or revolutionary energy storage. Bullets stay. But specialized roles are already transitioning. Snipers might eventually use electromagnetically assisted rounds for extreme precision. Anti-material rifles could incorporate hybrid propulsion systems. Squad-level weapons might add laser designators or guidance systems. The transformation won't be sudden. It'll be incremental, with conventional and directed energy weapons coexisting for decades. Now that you've seen why caseless ammunition failed from heat, why railguns collapsed from barrel wear, and why lasers dominate only specific roles, here's the truth. Future guns will absolutely still use bullets, but not the bullets you're imagining. Infantry rifles in 2045 will fire projectiles propelled by chemical energy, but those projectiles will be lighter, smarter, and more lethal than anything we have today. The ammunition feeding them will use polymer cases or fully caseless designs once thermal management problems get solved. And supporting those riflemen will be laser systems destroying drones and rockets, railguns firing from ships if China's breakthroughs force the US to restart programs, and electromagnetic assisted weapons bridging the gap between gunpowder and pure energy. The US Navy's $500 million railgun failure taught a brutal lesson. Revolutionary technology means nothing if you can't sustain it in combat. Barrel life matters. Maintenance matters. Logistics matter. A weapon that works perfectly in a lab but fails after 30 shots in the field is worthless. That's why bullets survived every challenge. They're proven, reliable, effective, and most critically they work when everything else fails. But they're not static. They're evolving faster than most people realize. The future of warfare won't be bullets or lasers. It'll be bullets and lasers, railguns and hypersonics, gunpowder and directed energy, all integrated into weapon systems that give soldiers every advantage technology can provide. Bullets aren't disappearing because 3 separate billion-dollar programs tried to kill them and failed. They're disappearing from specific roles where alternatives work better but dominating everywhere else. The question was never whether bullets would disappear entirely. The question was what role they'd play in an increasingly complex arsenal. And now you know the answer. Still the dominant one for ground combat, but no longer the only one. Welcome to the future. It's louder than you think, but also a lot brighter.